All right, today we're going to go ahead and talk about parallel and perpendicular lines. Your goal at the end of this lesson is to be able to decide whether two lines are parallel, perpendicular, or neither. The homework is Linear Equations Review, worksheet number 3. So we're going to start with parallel lines. So a line is said to be parallel to another line if it has the exact same slope and a different y-intercept. So if we're looking at the equations, sorry, that should be a C. If we're looking at the equations, if the slope is the exact same, but the y-intercept is different, these would be considered parallel lines. So this would be something like y equals 3x plus 2 and y equals 3x minus 4. Parallel lines would never intersect. They would have no points in common, and they must have the same slope. So if I were to go ahead and graph these two lines over here, 3x plus 2, I'd start at positive 2. My slope is up 3, right 1, up 3, right 1. Sorry, my pen keeps going out. So this would be that top line, 3x plus 2. I'll go ahead and switch colors. So we'll graph this one in green, and then I'd go minus 4, 2, 3, 4. 3 would be up 3 over 1. And so as you can tell, with these having the same slope, these are parallel lines. They will never cross. And they have no points in common. So the next thing that we're going to talk about is perpendicular lines. So a line is considered to be perpendicular to another one if the slopes are these things that are called opposite reciprocals. Opposite reciprocals. So if we think about that, the opposite would be the opposite sign, so a positive and a negative sign. And then reciprocals means that flipped fraction. So if they are a flipped fraction and they are the opposite signs, then they are perpendicular. So these lines would intersect once and they would form 90-degree angles. So this would be something like y equals 2x plus 1. And then we'll go ahead and switch colors, and we'll go y equals negative 1/2 x. And then it doesn't matter about the y-intercepts on these ones, just the slope. So I'm going to go ahead and graph that top one in green. So I'm going to start at positive 1. I'm going to go up 2 over 1. So my line would look like this. Then I'm going to switch to my orange, and I'll graph that negative 1/2 x minus 3. So this means I'm going to go down 1, right 2. So it would look like this. Sorry, my line stopped. There we go. And so these would be those perpendicular. They form at that 90-degree angle right there. So in order to determine if something is parallel, perpendicular, or neither, you need to start by determining the slope of the equation. So the slope is that number that is before x. So these are 6 and 6. Then you have to ask yourself, are those the exact same? Are they opposite reciprocals, or are they neither? So on the top one, my slope is 6. On the bottom one, my slope is 6. So those would be parallel because those are the exact same. Example number 2, my slope on the first one is 2/3 and negative 3/2 on the second. So those are not the exact same. So they cannot be parallel. They do have the opposite sign. The first is positive and the second is negative. And then they are flipped fractions of each other, so those would be perpendicular. Example number 3 is talking about our y equals and our x equals, so we have to think back to our horizontal and vertical lines. So if I have my coordinate plane or my axes here, and I have a y equals 6, so we'll go ahead and use blue for that one. That's going to be up here, and it's going to go horizontal, and so the slope of that would be 0. Then if I go ahead and use green and do my x equals 2, that's going to be over here. It is a vertical line, so my slope is undefined. Those do cross at a 90-degree angle, so those are still perpendicular even though we don't have the straight slope in those. Example number 4, we're back to our normal equations. So I have a 6 and a negative 6, so my first slope is 6, my bottom slope is negative 6. Those are not the exact same, so they are not parallel. Those are opposite signs. One is positive, one is negative, but they are not flipped fractions of each other, so they are not perpendicular, so we would call those neither. Example 5 is kind of a fun one. In order to determine your slope, you need to have them solve for y. So neither of these are solved for y yet. So the first thing I'm going to do on number 1 to get y by itself is I'm going to go ahead and divide everything by a 2. So when I do that, my equation would become y equals 2x minus 3, and my slope is right there, which is that 2. The next one, the first thing we need to do is go ahead and distribute that 2, so we can get rid of those parentheses. So y minus 4 equals 2x plus 2. We're still not solved for y yet, so I'm going to go ahead and add that 4 over. And so this would become y equals 2x plus 6. My slope there is that 2. And so when we're looking at these slopes, they are the exact same. So these two lines, even though they look very different in the original problem, are actually parallel to each other.